We can also organize data using a matrix. So a matrix is going to work much like a table to store information, but it won't have any of the headings or any of the descriptive text. It focuses solely on the data. So each row and column can correspond to some title or heading, but since it strips away all the text and focuses only on the data itself, comparisons and operations are done much more easily. For instance, given the following ticket information at the movie theater, the data could be displayed in a matrix. So when I look at this ticket information, I see I have three different show times. I have matinee, an evening, and then twilight shows. So each of these three have three different prices: adult, child, and senior. So it seems like I could construct this in a 3x3 matrix. Okay, and let's see what that'll look like. Slide this up, and here's a 3x3 matrix. It looks like the columns are going to be the different times of the day the shows occur, and it looks like the rows are going to be the different prices for the adult, child, and senior. So my first column will be the matinee shows, the second column will be my evening shows, and the final column are my twilight shows. While the first row is my adult prices, the second row the child prices, and the third row will be my senior prices. Notice the twilight shows are all $4, so the adult, the child, the senior, all $4. But all the rest of the data from my ticket information is shown nicely and neatly in this matrix. So we could do some kind of operations or comparisons with this if we needed to. But the general thing to take away here is we can take information in the real world, like ticket information for shows, and we could put it in a matrix so later on we can do something with it.